Hello everyone, I'm Aditi Kinkhabwala from New LJ Institute of Engineering and Technology. In this lecture, we would be studying about the chapter trees. So the concepts which we are going to cover in this lecture is tree definitions and concept and representation of binary tree. Now, starting with the definition of tree, what are trees? So we can say a tree is set of one or more nodes where one node is designated as a root node and all the remaining nodes are partitioned into the left of a root node or a right. So it can also be said as they are partitioned into non-empty sets. Non-empty sets means they have a node in there, each of which is a subtree of the root. So basically a tree is having a main node, root node, and all the other nodes. There are different types of nodes such as child node and leaf nodes. So a tree is a structure which is mainly used to store data in hierarchical nature, right? So it is basically a hierarchy. It is following a hierarchy. That is, here if you see P, then there is Q and R, then there is A, B, C, D. So a hierarchy is maintained. So where they are used, so tree is widely used to manipulate arithmetic expression, construct symbol tables, and for syntax analysis. So in these specific applications, tree are used. For example, arithmetic expression means what? So a plus b plus c. So what happens here? So first we know that plus is having the same precedence and associativity is left associative. So it starts from left to right. So first what will happen? A and b, and in A and B, we will be adding A and B, and whatever is the answer, we would be adding C to that answer, right? So what is this? This is basically a tree which is following a some kind of hierarchy. So symbol tables and for syntax analysis also trees are used. Now let us see some basic terminologies related to tree. Now what is a root node? So the topmost node of the tree is a root node, and if it is a null, then that means that the tree is empty. So here A is a root node. What are the subtrees? So if R is not null, that is if tree is not empty, then it must be having some subtrees. So in this case, if we see T1, T2 and T3, all of them are subtrees of root R, right? So if root node is there, so this is one node, right? So one edge is going towards this. T1 is one subtree, then T2 and then T3. For that, we should have a condition that R should not be equal to null. That means tree should have a root node, then only it will have further subtrees. What is a leaf node? A node that has no children is called leaf node or the terminal node. So in this case, if we see E, F, J, K, H and I are all the leaf nodes because they do not have further nodes. That means they are terminating the tree. What is a path? It is a sequence of consecutive edges is called a path, right? So it is basically sequence of consecutive edges. For example, the path from root node A to I is given as, if we see this is root node and this is the destination. So what is the path? The consecutive edges, that is A to D and then D to I. What is an ancestor node? So ancestor of a node is any predecessor node on the path from root to that node. The node does not have any ancestor. Which node? We can say that root node does not have any ancestor. So ancestor means there are two concepts, ancestor and successor. So if we see what is the successor, so for example in this situation B, C and D, for B, C and D, A is the ancestor and the successors, like after B, C and D we have E, F, G, H and I. So these are successor. The successor of B is E and F and predecessor is A, right? So we can say ancestor is any predecessor node on the path from root to S, so which precedes it. So in given tree, if we say A, C and G, we can say what is for K, what are the ancestors? G, C and A. Okay, so these are the ancestor node. What is descendant node? So descendant node is any successor node on that path. Okay, so root node does not have ancestor. and E, that is leaf nodes. All the leaf nodes does not have descendant node, right? So in the given tree, if we see C, G, J and K are descendant of root A because they are the successor of root A. So ancestor is also known as predecessor, and successor and descendant nodes are the same synonyms. Okay. Next is level number. So every node in a tree is assigned a level number. So they are there at each levels. Okay, so in such a way that the root node is at level 0, children of root node are at level 1, and so on. So every node is one level higher than its parent. So if these are the second level 1, then these are at the level 2. So if these are parents, so definitely these are children, so they are at the level number plus 1. Now what is the degree? Degree of a node is equal to number of children that a node has. So degree of a leaf node is 0 because it does not have any children. So if we see for this tree, the root node A, what is the children? There are basically 3 children, right? So the degree of the root node A is 3. What is in degree? So in degree of edge is the number of edge arriving at that node, and out degree is the number of edge leaving that node. Okay, so it is mostly used in graphs. Here also we can say number of arriving would be like arriving for trees would be 1 only, right? So leaving out degree could be more than 1, 2 or more than, basically we can say 1. Now there are 6 type of trees known as general trees, forests, binary search tree, expression trees, and tournament trees, right? So if you are given a question that you need to enlist the different types of tree, these again in this we have different kind of trees, such as for trees we have complete binary tree, then we have perfect binary tree, so on and so forth, right? So we will discuss about binary tree first. What is a binary tree? Again, it is a data structure. It is a data structure wherein we have nodes and it follows some kind of hierarchy. So it is a data structure that is defined as collection of elements called nodes, right? So in the binary tree, the topmost element in the binary tree, topmost element is known as root node, and in binary tree, we know what is binary tree by, that means 2. So each node has 0, 1 or at most 2 children, not more than that. A node that has 0 children, we know that it is called a leaf node or a terminal node. Every node contains a data element, a left pointer which points to the left child and right pointer which points to the right child. So if this is a root node which is A, so this is a data, then it has a left pointer. Okay, so here we have a left pointer and here we have a right pointer which points to the left and right child. So if it is in a linked list, we can represent in this way, that here a left pointer and right pointer which again points to some another data and which in turn has some left pointer and right pointer. So the root element is pointed by root pointer. Similarly, in linked list, we have a start, right? So we start a linked list by using a start pointer. Similarly, the root element is pointed by root pointer, and if root is equal to null, then that means that the tree is empty, right? So let's see in this figure, if we see R is the, here 1 is the root node, basically it is denoted by R, and then there is T1 and T2. T1 is the left subtree and T2 is the right subtree, right? So it is the left successor of the root node and T2 is right successor of the root node. Now with respect to binary tree, again let us have some other terminologies. Now what is a parent? So parent is basically, so from root, if we say there is root node and there are 2 terminals T1 and T2 or subtrees, we can say T1 and T2 are called the child, and who is the parent? Root is the parent. Level number, right? So root starts from level 0 and then the child follows the other levels from 0. If this is level 0, the child are at level 1, their child are at level 2, and so on. degree is equal to the number of children a node has. So this root node 1 has degree 2 because 2 children, here also 2. This node has 2 children, 6 and 7, so degree is 2. 4 has degree 2 again. This 5 has no further children, so degree is 0. What is a sibling? So a sibling is basically all the nodes that are at same level and share the same parent. They are called sibling. For example, 2 and 3 are at the same level, so siblings has to be at the same level. So 2 and 3 are siblings, and because they are siblings, because they have same parent. In this case also, see, all these are not siblings. If they 8 and 9 are siblings because they have the same parent 4. 10 and 8 are not the siblings because the parent are different. So we have to see that same level and share the same parent. Now, what is a leaf node? Again, a leaf node or a terminal node is a node which does not have any children. What is edge? So it is a line connecting the node to its successors. A binary tree of n node has a binary tree of n nodes has exactly n minus 1 edges because every node except the root node is connected to parent via an edge. Okay, so if you see what is a edge, it is a line connecting a node to any of its successors, right? So this is, we can say it is an edge. What is a path? A sequence of consecutive edges is a path. For example, the path from root node 8 is given as 1, 2, 4 and 8, right? So it is consecutive edges, and this edge is a single line connecting n to its successor, right? So if 1 is connecting, if 3 is connected to 1, right? So 3 successor of 1, so they are connected by an edge, and similar such different multiple edges forms a path. What is depth? So depth of a node is given by the length from root to the given node, and the depth of, so it is similar to level only, so depth of root node is 0. What is height of a tree? It is number of nodes, total number of nodes on the path from root to the deepest level, so the most deepest level of the tree. So a tree with only root node is at the height 1. This is at height 1, 2, 3 and 4. A tree with only root node has a height 1. Okay, so it is equal, here it is equal to the number of children the node has. So a binary tree of height h will be having at least at most 2h minus 1 nodes. Now let us see what is complete binary tree. Complete binary tree is a tree that satisfies two properties. First, the complete binary tree, every level should be completely filled. So the last level might not be completely filled, otherwise all the levels should be completely filled, and all the nodes appear as far left as possible. Now if you can see here 1, 2, 3, 4, 5, 6, 7, till here the nodes are completely, so the all the levels are completely filled. Last level might not be filled, but when it whatever till whatever amount it is filled, it has to be from the far left, so from left to right. It should not be the case that here we don't have nodes and here we have two nodes. It should always start from the left. So this word is very important. These two conditions you need to write in the definition of complete binary tree. So in a complete binary tree, there are exactly n nodes, and level r of t can have at most 2 raised to r nodes. Now let us see the representation of binary trees in the memory. Now how these binary tree, now this is a representation from user perspective, right? So we are very comfortable with this kind of visualization. But now in memory, how this binary tree is stored, let us see that. So in computer's memory, binary tree can be maintained either by using a linked representation or by sequential. So it has a sequential representation as well as linked representation of binary tree. Let us start with the sequential representation. So sequential representation of tree is done using single or one-dimensional arrays. So it is a very simple technique for memory representation, but it is inefficient because it requires a lot of memory space. So sequentially, it can store the memory. Now let us see how it is stored sequentially. So see here, the root of the tree will be stored in the first location. Okay, so this 20, for example, we are ignoring the 0 over here. It might be there, so we are ignoring the 0. The root, if it is stored at the first location, now where the children will be stored? So children will be stored at 2k. So what is 2k? If k is 1, so this is 15 will be stored at 2 into 1 at second location, and 35 will be stored at 2 into k plus 1. So 2 into what is k? 1 plus 1. 2 into 1 is 2 plus 1, 3. So 35 is stored at 3. Now where this 4 will be stored? So again, now what we have to see here? So 2 is basically, this 12 is a child of 15. So where 15 is stored? 15 is stored at 2. So k is 2. And now where 12 will be stored? 2 into k. So 2 into 2, 4. So 12 will be stored at 4. Again, 35 is at location 3. So what is 2k plus 1? 2 into 3 plus 1. So it is 6 plus 1, 7. So at seventh location, 39 is stored. So if you can see, at seventh location, 39 is stored. Now where 30 left of 35 will be stored? So if this is at the third location, this would be at 2 into 3. Once again, let's see this. This is stored at first location. So this is 2 into 1 of second location, and this is 2 into 1 plus 1 third location. Now this would be stored at 2 into which location? 15th is stored at the second location, so 2 into 2, which is fourth location, where this will be stored 2 into 2 plus 1. So fourth and fifth location, where this will be stored. This is at third location, so 2 into 3, sixth location. This would be at 7. Now see, this does not have children, so this two positions would remain empty. If you can see, this will remain empty. Then 16 would be again fifth. So 5 twos are 10. So at 10th location. 5 twos are 10 plus 1, 11. So 18 will be stored at 11, so on and so forth. So if a node does not have children, that memory, so this would be unutilized, right? So this is one of the drawback of sequential representation. Okay. Now let us see the linked representation of binary tree. So every node will have three paths. First is data element, second is pointer to the left node, and third is pointer to the right node. So we have a data element which would be by integer data. Now this is a left pointer, so we will be creating a node and struct nodes. This star left is the syntax, and similarly for right we have a right pointer. So this is how we can visualize the linked representation. So this pointer will, if this is at address 500, this would be 500. If this is a 300, this would be 300. Similarly, the further nodes are stored in this manner in linked representation. Now see how it is stored in main memory. So we have data. So for example, we'll start at this location, third location. So if you see here, the at third location, so where is root stored? So root is responsible for storing the root pointer. So it is stored at location 3. So 1. Okay, so this is 1. And where is left of 1 is stored? So we will see this 2. So if you see here, what is the left pointing to? 5th. So at 5th, we would be having 2. Where is left of 2 stored? So at 9th. So on 9th, we'll see the left of 2, which is 4. All the leaf nodes, we will see that they have left and right as -1, right? So null, because they don't have any left and right pointers. So this is how linked list is stored. So linked represent binary nodes are stored in linked formation in this way that it has left and right pointers. So we have seen the sequential and linked representation and as well as basic definitions of tree in this lecture. Thank you.